students in grade 8. Today we are going to make a quick revision in the first term, starting with the unit 1 with lesson 1, classification of some elements in the modern periodic table. We have the first real table for classifying elements is Mendeleev, which arranged elements ascendingly according to their atomic weight. And he said that the elements that have the same properties, put them in vertical columns and called them groups. And the elements that have the similar physical properties are put in horizontal rows and called them periods. And also he dealt with the isotopes, and we said that the isotopes are different forms of the same elements which have the same atomic number but different mass numbers, so they have different neutrons. Then the second classifying element for the scientist called Moseley. But before the classification of Moseley for the elements in his table, we have a scientist called Rutherford who discovered the positive protons inside the nucleus. But Moseley named these positive particles with the term protons, or we can say the atomic number. Then Moseley classified elements according to their atomic number ascendingly from the left side to the right side. Also, he added the zero group, which called the inert gases at the end of the table, and specified a place below the table for the F block, which is lanthanide and actinide series. Then the modern periodic table, a group of scientists classified the elements in this table according to their atomic number ascendingly, and also the way of filling energy sublevels with electron. And in this table, there is a scientist called Bohr who discovered the main energy levels, and their number is 7, K, L, M, N, O, P, and Q. Don't forget that we have 4 energy sublevels, their symbols S, P, D, F. At the end of the lesson, we talked how can we detect the location of elements by knowing their configuration and their energy levels. So, by knowing the number of energy levels for the elements, we can detect the number of periods. And the number of electrons in the outermost energy level tell us about the number of groups. For example, if I have an element called sodium, its atomic number is 11 when I distribute it to 8, 1. So it has 3 energy levels, so it's located in period 3. And has 1 electron, its outermost energy level, so it's located in group 1A. This for lesson 1. Then we started in lesson 2, talks mainly about how can we determine some properties for some elements, the graduation of properties, starting with the first property, which is the atomic size. Atomic size is determined by knowing the atomic radius, and its measuring unit is picometer, which is 1 times 10 power negative 12. And we see the graduation of the atomic size in the table. It decreases through the same period and increases through the same group. The second property is the metallic property, which increases in the same group and decreases in the same period. The third property, the non-metallic property, decreases in the same group and increases in the same period. And also there is a scientist called Berzelius who classified the elements into 4 main types: metals, which have 1, 2, or 3 electrons in their outermost energy level; non-metals have 5, 6, or 7 electrons in their outermost energy level; metalloids, which have the properties of metals and non-metals, and their numbers is 6: silicon, germanium, antimony, arsenic, tellurium, and boron. Also, we have an inert gases, which their outermost energy level are completely filled with electrons, with 8, except the helium, which is saturated with 2. The second part of the lesson talks about the chemical properties of metals. When they react with acid, they form salt of an acid and hydrogen gas evolves. And when the metal oxide dissolve in water, they form alkaline solutions, which we can call it as the basic oxide. So alkaline solutions are a part of the basic oxide. And the second one, the chemical properties for nonmetals. Number one, they cannot react with diluted acid. So if the carbon reacts with diluted HCl, no reaction takes place. And the second chemical property for the nonmetals, when they react with oxygen, form acidic oxide that dissolve in water and forming acidic solution, like when the CO2 dissolves in water, forming carbonic acid, which is H2CO3. Also in the lesson 3, starting with the main groups in the modern periodic table. Let's see the table. The modern periodic table here, the main groups in this lesson, talks mainly about the 3 main groups. Group number 1, which is 1A, alkali metals are located at the maximum left side of the modern periodic table, and they are very active elements, starting with the lithium, sodium, potassium, rubidium, cesium, and francium. And cesium here has the most active elements, and it has the largest atomic size, and it can lose its valency electron easily. Elements which are called alkali metals that located in group 1A, they are very active elements, so when they react with water, they form alkaline solution and hydrogen gas evolved with a pop sound. Their outermost energy level has only 1 electron. Their valency is monovalent. They tend to lose the electrons and the changes into positive ion during the chemical reaction. Most of them, their densities is lower than the density of the water, but the higher one are rubidium and cesium, so they sink in the water. And most of them are kept under kerosene surface to prevent their reaction with the moist air, except the lithium, which is kept under the paraffin oil. The second group in this lesson talks mainly about the group 7A, which we can call it as halogens. Their elements are fluorine, chlorine, bromine, iodine, and acetatine. Their outermost energy levels contain 7 electrons. They are also monovalent because they tend to gain electrons and changes into negative ion. They are diatomic elements, so they don't exist individually in nature. Also, they can replace their elements in their salt solution. So if the chlorine reacts with potassium bromide, so the chlorine can replace bromine, bromine can replace iodine, and so on. So it's a condition for the element to replace another element in the group 7E to locate below it in the group 7E. We end this lesson by the inert gases. They are completely filled with electrons, and they are stable in ordinary conditions. The last part of the lesson talks mainly about the uses of some element. We can use the liquefied sodium in gaining vapor, which is used to generate electricity, silicon in making and manufacturing electronic devices, cobalt preservation of food, and liquefied nitrogen in preservation of cornea eye as its boiling point reached to negative 196 degrees Celsius. A lesson 4 in this unit talks about the water. We know that the water, its chemical formula is H2O. It has 2 single covalent bonds between their elements, but when the molecules of the water combine together by a bond called hydrogen bond, it's a unique structure, so it has abnormality of its properties, whatever its physical or chemical properties. They're physical, they exist in 3 states. High melting and boiling point, or freezing point also. They can be separated easily into hydrogen and oxygen by electrolysis of it by using the Hoffman voltmeter, as we have cathode and anode. The hydrogen gas evolves at the cathode and the oxygen above the anode, and don't forget that the volume of hydrogen is double the volume of oxygen. Also, in the second part of the lesson, talks mainly about the meaning of the water pollution. It's the addition of any substance to the water which causes a change in its properties. And we have two types of pollutants, natural pollutants and artificial one due to the human activities. And we end the lesson by the types of the water pollution, which are biological pollution, chemical pollution, thermal pollution, and radiant one. Excellent, the radiant one. The last part of the lesson talks about how can we protect the water from pollution by avoid throwing wastes in the water, increasing the awareness about the importance of the water, don't store water in a plastic bottle, and we have to disinfect the water by a periodical period, from one period to another, to make sure about the validity and the quality of the water that is able to drink it. Then we started in Unit 2. As we know that Unit 2 talks mainly about the atmospheric pressure. But before meaning the atmospheric pressure, we have to know that the Earth has an atmospheric envelope surrounding the Earth's planet and is affected by the gravity force. And we have something called atmospheric pressure. It is the weight of air column in a unit area. And the atmospheric pressure is measured by a device called barometer, and we have two types of the barometer here: aneroid, that is used for determining the day weather, altimeter, that is used for the elevation of navigation based on the atmospheric pressure. Don't forget that the measuring unit of the atmospheric pressure is millibar or power. And also we classified the element or the atmospheric layers according to their change in pressure and temperature into four main layers. The troposphere, which is called the disturbed layer, as all weather phenomena happens in it. The stratosphere, which is called the ozonic layer, as it contains the ozone gas or the ozone layer, which protects the Earth from any harmful radiations coming from the sun. We have the mesosphere, the coldest layer, which is called the vacuumed one, as it has a limited amount of hydrogen and helium. And finally, we end with the thermosphere, the hottest layer. Its temperature reached to 1200 degrees Celsius. Also, we have a phenomena called aurora phenomena that happens at the upper part of thermosphere, actually surround the ionosphere by the presence of Van Allen belt, which is scattering the cosmic harmful radiation away from the Earth. We end this lesson by a layer called exosphere, which all the atmospheric layers are inserted in it, and the satellite floats in it. So when you study the layers, you have to make a comparison between them according to their atmospheric pressure in each layer, the temperature for each one, the thickness for each one, and also the importance for each one. And the second lesson talks about two dangerous phenomena happened in the atmosphere, starting with the erosion of the ozone layer by knowing the ozone hole that increases in September month in each year due to the pollutants that increases its hole, such as freon, CFCs, methyl bromide, halogens, and nitrogen oxides. And the second phenomena talks mainly about the global warming phenomena, which happens due to the greenhouse gases, with its percentage increases in the air, like the CFCs, carbon dioxide, water vapor, nitrous oxide, and methane gas. We end the lesson with the meaning of the greenhouse gases, which is the trapping of the ultraviolet rays in the atmosphere and doesn't penetrate it, so it causes increasing in the percentage of CO2 that leads to increasing in the temperature of the Earth, called the global warming phenomena. This for Unit 2. Starting with the Unit 3 with the title Fossils. Let's see the fossils. Fossils are traces and remains of an old living organism that preserved in the sedimentary rocks. They classified the fossils according to the way of formation into a complete body fossil like mammoth and amper, mold fossil, ammonite, limulite, trilobite, cast fossil like fish and ferns, and petrified fossils like petrified wood or dinosaurs' eggs or dinosaur teeth, which is formed by a process called petrification, in which the minerals replaces the organic matter or the wood matter in it part by part and takes millions of years to be formed. The second part of the lesson talks about the importance of studying fossils. Why we study fossils? Number one, to determine the age of the sedimentary rocks. Number two, to study the life evolutions as the life appears from the simplest to the complicated. So in plant world, gymnosperm appeared before the angiosperm, and algae appeared before mosses and ferns. In the animal world, invertebrates appeared before vertebrates. And the first vertebrate that appears was in the sea, which is fish, then amphibians, then reptiles, and ends with the birds and mammals. So humans are the last species that appeared on the Earth's planet. And don't forget that we have an Archaeopteryx, which is a link between reptiles and birds. The last importance of studying fossils for petroleum exploration. If they explore some exploratory rocks and find some of fossils which are called microfossils like radiolaria and foraminifera, it points to the age of the exploratory rocks and also suitable conditions for petroleum formation. The second lesson in this unit talks about the extinction, and what's meant by extinction is the dying out of all members of a certain species of living organism. And there are two types of reasons that cause extinction, whatever in old times and in recent times. In old times, like meteorites impact the earth, violent earth movement, volcanic eruptions, but the reasons of extinction in recent times, like the overhunting, the environmental pollution, and some human activities, and the climatic changes. The extinct animals in old times like mammoth and dinosaurs, in recent times like the dodo bird, which is an easy target for hunters, and quagga, which is a midway between horse and zebra. But the endangered species in the world like panda, ibis bird, papyrus plant, arowie or Barbary sheep, and a bald eagle. Then, in the second part of the lesson, talks about the meaning of the food chain. What's meant by food chain? It is the path of transferring energy from one organism to another through the ecosystem. And many food chains interconnected together form something called the food web. Excellent. Then the last part in the lesson talks about the types of the ecosystem, which is simple ecosystem that's strongly affected by the absence of one of its species, like desert, and the complicated ecosystem, which is not affected by the absence of one of its species, like the tropical rain forest. Then we talked about how can we protect the endangered species from extinction. Number one, by establishing gene bank. Number two, establishing natural protectorate. Number three, providing them with a place that provide them with food, water, and shelter. What's meant by natural protectorates are safe places that established on the earth to protect the endangered species from extinction. Like what? Like the Panda Protectorate, which is located in northeastern of China and protects the panda bear. Like the Yellowstone Protectorate, which is located in USA, United States, and to protect the gray bear. And the first Egyptian protectorate that established in Egypt is Ras Muhammad in 1983, which protected the colored fish and the rare species of coral reefs that is located in South Sinai. And don't forget the last Egyptian protectorate is called Wadi al-Hitan, that is located in Wadi al-Rayyan in Fayoum Governorate, and protect the skeleton the fossils for this whale's skeleton that is formed from more than 40 million years ago. And the shape of Ras Muhammad in the map looks like a shin. So we have 30 natural protectorates are established on the earth. About 50% of these protectorates are found in Egypt. So today in grade 8 we need a quick revision for the first term, starting with the unit 1 classification. Lesson 1 was a classification of elements. Lesson 2 graduation of some properties. Number 3 main groups in the periodic table. Number 4 the water. And also we talked about unit 2 starting with lesson 1 the atmospheric layers. Lesson 2 the ozone, erosion of the ozone and the global warming. And when we started in unit 3, we're starting lesson 1 with the fossils, its types and the importance of studying it. Lesson 2 talks about the extinction and how can we protect the endangered species from extinction. And what are the examples for the natural protectorates around us in the world. Thank you for your listening and I wish you a good day. Just study your lessons well, just answer different questions in the book and identify different types of questions. Just study hard. Wish you a happy day and with the best wishes. Bye bye.